Right, welcome everyone. So this is a continuation of lecture 12.1, visual displays of data. And yeah, we just started this whole section, right? Where I give you a couple vocabulary terms, terminology, population, sample, and then we were looking at some results of a election poll taken at Scofield Barracks, and we decided that the sample was too small, right? Because we sampled only 100 voters in Scofield Barracks, and also the sample was taken basically taken in a place that's not representative to the whole population of Hawaii. So let's continue with this for a little bit. So let's take a maybe bigger sample. Of let's do 20,000 voters, right? And let's say those voters are from all kinds of places across the islands. This time we found that 12,854, right, will vote for Biden, and 7,146 for Trump. Okay, and yeah, and we can calculate the percentage, right? So 12,854, right? If I divide it by the size of the sample, so 20,000. Right, and I would get 64.27%. And here I can do the same thing with the voters who responded that they would vote for Trump, also divided by 20,000, and I will get 35.73%. Okay. So this type of statistics, right, where we just display and analyze data, is called descriptive statistics. Okay, so now based on this, based on what we just found, we can make a conclusion, and our conclusion will be that, or prediction, right, that Biden will win the elections. So conclusion: Biden will win the elections. So this is this is called inferential statistics, right? When we draw conclusions based on our analysis. So inferential statistics. Okay, and also, right, we can conclude that the larger the sample, then more accurate prediction. Okay, that's true most of the time. Anyway, let me a couple more terms. So the first one is raw data. So raw data, and that's information or data that has not been processed or analyzed. Okay, so data and that hasn't been analyzed or processed. Okay, I have a couple more terms, couple more things, but let me give you, let's do another example. Let's actually do an actual example from your textbook. So this is example 1. So let's say somebody surveyed 25 families, and they discovered that they have the following number of kids or siblings. So number of siblings in 25 families. Okay, so yeah, there's some writing involved here. So 2, 3, 1. Maybe so this is the first example. I'll write all the data. Maybe in the next couple I will not. Then 2. There's only 1, 2, 3. So this is what is called the raw data, right? So it's just a list of numbers. 2, 5, 4, 3, 6, 5, 1, 6, 2, 2, and 2. All right. So we have all 25 items, and the first thing we'll do, we'll just simply make a table which will include how many times particular data item appears or occurs, right? So frequency, it's called frequency distribution. In other words, we somehow need to, right, we have that raw data that looks quite unorganized, just a list of numbers. So we need to organize it in some easier to see, easier to deal with way, right? So this is how many times a given item occurred in the data set. So in our case, right, how many families will have or had 1 child, 2 children, 3 children, etc. Okay, and in our table we'll also include something called relative frequency. So that is so some kind of percentage, right, represented by like say families with 2 kids, right? So we'll take the number of families with 2 kids and divide them by how many data points we have, or how many families there were. Okay, so percentage represented by an item. Okay, so we have that relative frequency. So that will be F over N. So that's that frequency, or how many times somebody's calling me. And this is total number of items. Alright, so you'll see what's going on as soon as we start making the table. Alright, so here's the table. On the left column we'll have number of siblings. Okay, and yeah, we'll just look at that that data, right? And there's some families with 1 child. Let me try to focus that. Alright, maybe that's better. Okay, so couple families with one child, two children, right, etc., etc. So this is what we put in that left in that left column. Okay, so I have 1, 2, 3, 4, 5, and there's one family or two families with 6 kids. All right. So now the second column will be frequency. Well, so here we just simply need to count how many of those families with one child, two children occur, right? So let's look at this. So I have here one child, here one child, another one, and I think, oh, there's one more. So there are 4 families with one child. Okay. Now we do the same thing with 2. Right, so I have 1, 2, 3, 4, 5, 6, and 7. Okay, so 7 families with 2 children. Okay, etc., etc. I'm not going to go through all those. I'm not going to count all those families, but I have 6 families with 3 kids, 3 families with 4 kids, 3 with 5, and 2 with 6. Okay, so that's that frequency. How many times a family with 1 kid occurs in our data set? Okay, so the third column, I have that relative frequency. I may have to split this lecture into a couple. Alright, so what do we do? So we take how many times? So that will be 4. Let's make it blue. 4 over total number of data points, right? So 4 families over total number of families. So 4 over 25, we divide it and we get 16%. Right? So that if we divide it, we get 0.16, but then we change it to percent. So here I have 7 over 25. So that's 28%. And then we keep going, right? 6 over 25. So that would be 24%. And then 12%. Okay, etc. And then 8% is the last frequency. Okay. So this is one of the ways to organize or display data, right? It's somehow it's easier to see, easier to look at this than just raw data over here, right? Sometimes that this type of displaying data, or showing data, organizing data is not particularly useful. Let me give you an example. So let's look at COVID cases by age. Okay, so I have age on the left, and then cases here on the right. This is just a silly example that I came up with. Okay, so 16-year-olds, 37 cases. So this is, I don't know, this is some data from the previous year, not from this year. 17 is 41 cases. And then 18, right? 63 cases, etc., etc. Right? We could keep going with that list. So problem with this is that with a lot of data and a lot of different age groups, right? We would have that left column would be quite long, right? Let's say the oldest person in Hawaii has, I don't know, 110 years, right? So you would have, I don't know, almost 100 different different numbers over here, right, on the left. And it wouldn't be particularly useful. It wouldn't be particularly well organized. So what we're going to do, we're going to group those ages, right? So we're going to go, let's say, from 0 to 15, right? And then you would have some number of cases. I don't know what that is, 267, right? Then the next group you would have from 16 to 31, right, or 32. We would have to figure out, right, how many of those ages is in each particular group, right? And that's what we'll do. Okay, so if we display the data in this way, right, it's gonna be called grouped frequency distribution. Just don't get scared by all those names, right? It's quite simple. So grouped frequency distribution. All right. And this is useful with large data sets. Like, so in the previous example we had 25 data points, right? And here, I don't know, that's maybe useful for data sets that have, I don't know, over 50 or something like that. Contain different items. Okay, so let's do an example where we'll do that, right? Organize our data in some groups, and then we'll also construct, and then based off that we'll construct a histogram. Okay, so let's say we have 40 students and they were asked how much per week they study. Asked for a number of hours. Spent studying per week. Okay, so I'm not going to give you all the data, but I'll make sure that the data I'll show you has the smallest number and the largest number. Okay, I think maybe I'll stop this lecture after I give you this data. Okay, so 26, 41, 45, 45, 25, and 32. Right, so this keeps going, right? There was 40 students, so we would have 40 data points, but I'm just not going to write it. Anyway, I'll record the next lecture and I'll post them.